NEET Model Exam 2025 Physics. Answers from question number 11 to question number 15. Question number 11. A source of EM of 12 volt and having negligible internal resistance connected to a variable resistor so that current in the circuit changes with time as root I, which is equal to T minus 1. Then total charge transfer by the source in the first second will be, right? So we need to find out what is a total charge transfer. That is nothing but Q, which is equal to integral of I dt within 1 second. So 0 to 1 seconds. So here we should know the value of I. Here we are given with root I, which is equal to T minus 1. So I, which is equal to T minus 1, the whole square. This is nothing but T square minus 2T plus 1. When I substitute this Q, which is equal to integral of 0 to 1, and here T square minus 2T plus 1 into dt. When we integrate this, and we'll get the value Q, which is equal to T cube divided by 3 minus 2 T square by 2 plus T. When we substitute the limits 0 to 1, we get Q, which is equal to 1 by 3 coulomb, which is nothing but 0.33 coulomb. So correct answer for question number 11 is nothing but option B. Question number 12. The coordinates of a moving particle at any time t are given by x is equal to alpha t power 3 and y is equal to beta t power 3. The speed of the particle at time t is given by. So we need to find out the velocity, that is velocity vector, which is equal to vx I cap plus vy j cap. We need to find out. So the magnitude of velocity or the speed is nothing but vx square plus vy square. Now we are given with alpha, which is, sorry, we are given with x is equal to, alpha t power 3. X is equal to alpha t power 3. From there, we can find out Vx is nothing but 3 alpha t square. Similarly, we are given with y, which is equal to beta t power 3. From there, we can get Vy, which is equal to 3 beta t square. So when we substitute this here, the magnitude of velocity V becomes root over 3 alpha t square whole square plus 3 beta t square whole square. When we solve this, we get finally the answer as 3 t square root over alpha square plus beta square. So correct answer for question number 12 is option C. Question number 13. An alpha particle, after passing through a potential difference of V volts, collides with a nucleus. If the atomic number of the nucleus is Z, then the distance of closest approach of alpha particle to the nucleus will be, right? Let us assume an alpha particle comes with a charge that is nothing but 2e, and here some nucleus is there whose charge is taken to be Ze, right? So the minimum distance of approach, let us take, that is d. First, initially, it has been accelerated through a potential difference of E. So this will be first having the kinetic energy, okay, will be equal to the potential energy between this nucleus and the alpha particle, right? We can have like this. So the kinetic energy will be nothing but 2 electron volt, which is equal to K. Q1 is nothing but charge on nucleus and the charge on this alpha particle divided by the distance between them. What we have to find out? We need to find out the closest approach, distance of closest approach, right? So we need to find a d. So D, which is equal to, before that we can cancel out this E, 2E with the 2E, remaining is nothing but D, which is equal to K value is nothing but 9 into 10 power 9. Okay, let us keep Z as it is, divided by V as it is, and charge on electron is nothing but 1.6 into 10 power minus 19 coulomb. So when we get the value of, finally, when we solve this, we get 14.4 Z by V angstrom. The correct answer for question number 13 is nothing but option A. Question number 14. In which of the following case of spherical lenses, as shown in the figure, the emergent ray is parallel to incident ray? Answer for this question is nothing but directly we can write option D, because here in the case of concave and convex part of this lens, both R1 which is equal to R2, both the radii of curvatures are equal. So the emergent ray will be parallel to incident ray. Question number 15. A conducting ring of mass 2 kg and the radius 0.5 meter is placed on a horizontal plane with the current 4 ampere. A magnetic field of 10 Tesla is switched on horizontally at t is equal to 0. The initial angular acceleration of the ring will be. Let us assume a ring is placed like this, and whose mass is taken to be 2 kg, and its radius r is taken to be 0.5 meter, and placed on a horizontal plane with the current which is flowing through that is nothing but 4 ampere, right? And the magnetic field is passing through that like this, horizontal like this. So if I just take this as magnetic field, so this is going to experience a torque which is equal to, magnitude of the torque will be equal to mv sine theta. Here the angle between m and b definitely must be 90. So this torque tau, which is equal to m into b. M stands for magnetic moment. The formula for a magnetic moment is nothing but I, A, B. I stands for current, A stands for area cross section, and B stands for magnetic field. And also, we know that this torque tau can also be written as I into alpha, where alpha stands for angular acceleration. This is the quantity we supposed to find out, right? So let me take this as equation number 1. Let me take this as equation number 2. When we equate 1 and 2, we get the expression like this. That is I alpha, which is equal to I area of cross section. We can write that is nothing but pi r square into b. So what does this I stands for? I is nothing but moment of inertia of the ring along the diameter. So that value is nothing but I, which is equal to m r square divided by 2. When I substitute these values, alpha will be equal to, this current is nothing but 4 ampere. This I stands for actually current. This is I for current. This is nothing but moment of inertia, right? And into the value of pi we can keep as it is into r square, and the value of b is nothing but 10 Tesla whole divided by, and I'm just going to take this mr square, m r square into 2. So r square get cancels. And what is the mass of this ring? Mass of this ring is nothing but 2. So this 2 can be cancelled. Remaining alpha will be equal to, when we solve this, we get 40 radian per second square. So the correct answer for question number 15 is nothing but option A. We'll see in the next video.